Hey, it's Mr. Day, and we're back. Now we're working on similar triangles, and they're not only triangles, they're right triangles. Of course, when you think right triangles, you should be thinking hypotenuse and Pythagorean theorem in order to find the hypotenuse or the missing legs. So let's go to the board and check it out. All right, so this question says to draw a right triangle with hypotenuse 10 units and one of the legs 6 units, what is the area of the triangle? So let's look at that now. And we've got a right triangle, we've got 6 units here, and the hypotenuse is 10. We don't know what this is, so we'll call it X. Or, in fact, why not call it B? Just to stay consistent with our Pythagorean theorem, this is C and this is A. Now, first of all, we have to find the area. The formula for area is 1/2 base times height. We need to find the height. So we're going to have to find B. To find B, we use the Pythagorean theorem. And C squared equals A squared plus B squared. That means that 10 squared equals 6 squared plus B squared. 100 equals 36 plus B squared. And we subtract 36 on both sides and get, I'm going to move this up over here, we get 64. B squared equals 64. Take the square root of both sides, and B equals 8. Great. Now we know that B equals 8, and we can use that in order to find the area. We're looking to get the area of this triangle, and we know that area equals 1/2 base times height. 1/2 base times height, now we know it, is equal to 1/2 8 times 6. It's actually 6 times 8. But it gives you the same thing. In the end, 1/2 of 48 is equal to 24. And there we go. Now this second part is to draw a second triangle similar to the first, but smaller by a scale factor of 1/2, 1 to 2. Calculate the area. So again, 1 to 2 means the new one is 1/2 of this. So let's do that. Second triangle, we'll do it in green. And we'll do it right under here. Now, it's going to be a right triangle, so we got that. And we know it's going to be a scale factor of 1/2, so each of the sides are going to be 1/2. A is going to be 3, B is going to be 4, and C is going to be 5, just because we know similar triangles are going to have sides that are in proportion to one another. So and for instance, the B here is 1/2 of this, and we'll call it B prime, A prime, and C prime. And we know that A prime is equal to 3, which is equal to 1/2 of A, which is equal to 1/2 of 6. That's the mathematics of it. 3 equals 3, okay? And I don't have to do this with all of them, but that's the basics, that's the understanding. And it's pretty simple because you know that 4 is 1/2 of 8, 3 is 1/2 of 6. And 5 is 1/2 of 10. But they asked for the area, so then we know the formula for area is 1/2 base times height, and that equals 1/2 B, which is 3, times height, which is 4, which is equal to 1/2 of 12, and that equals 6. Okay, so now we're comparing the two areas, new to original. Okay, so the new one is 6, and the original was 24. So what we write is, the new one, 6, we'll write it in green actually. We'll do green, 6, and then 24, which was the bigger one. Now, didn't we make the smaller one 1/2 of the original one? Yes, we did. Yet, at the same time, this is 4 times smaller. So what we learned from that is that area is going to be the scale factor squared different than the original. That's how it works. So you're noticing that hopefully from other questions that you're doing. This question used a scale factor of 1/2, so perimeters would be halved. So if you had a perimeter of 30 for the first part and it got halved, then you'd have a perimeter of the second shape would also be halved, it would be 15. But the areas don't get halved, they get 1/2 squared, which is 1/4, so they get cut in a quarter. So as it says here, this is an area of 24. The larger shape is 24, and the smaller shape, in the case of triangle, is 6, 1/4 of 24. So looking at that, the new is equal to 6 is equal to 1/4 of 24. And so it's 1/2 squared 24. The scale factor squared times 24 gives us 6. That's it. That's what we're talking about. And all these questions have so that's it. That's what we're talking about. That all these questions have basically the same conclusion, and you're seeing it in different ways. This one included the Pythagorean theorem, so we had a little bit of bonus, a little bit of extra work to get there. But, hey, it's all fun. It's all geometry. It's all math. It's all algebra. And it's all coming at you for the good of your mental health.